Imagine, for a moment, a cosmic game of hide-and-seek played on a scale so vast, so mind-boggling, that the playing field is our entire solar system, and the quarry has remained unseen for centuries. Could it be that after decades of searching, after countless nights spent gazing at the stars, we are finally on the verge of finding the ultimate celestial fugitive, a planet lurking in the cold, distant abyss beyond Pluto? Fasten your seatbelts, fellow stargazers, because the story unfolding is one of mystery, cutting-edge technology, and the potential rewriting of everything we thought we knew about our cosmic neighborhood. Our tale begins with a subtle anomaly, a cosmic whisper that has tantalized astronomers for decades. Picture this: distant celestial bodies, far beyond the familiar orbits of Neptune and Pluto, seemingly dancing to a tune played by an unseen conductor. Their movements, their orbital paths, hinted at the presence of something massive, something exerting a gravitational pull that couldn't be accounted for by the known giants of our solar system. It was like feeling a phantom breeze, a subtle tug that suggested a hidden force at play. This enigma gave birth to a legend, the whispered name of a hypothetical world, Planet X. For years, it remained a tantalizing possibility, a shadowy figure on the fringes of our solar system. Traditional methods of planetary hunting, relying on the faint light reflected by distant objects, came up empty. Think of it like searching for a single dark pebble on an enormous, dimly lit beach. The vast distances and the potential darkness of Planet X rendered it invisible to even our most powerful telescopes. Some began to doubt its existence, relegating it to the realm of cosmic myths, a story told under starlit skies, but never proven. Yet, the persistent gravitational anomalies refused to vanish, like an echo in the vast emptiness of space. Then came a game changer, a technological leap that promised to pierce the veil of cosmic secrecy: artificial intelligence. Google AI Studio, a powerhouse of data analysis, was handed an unprecedented challenge. Forget searching for a faint glimmer of light. Instead, the AI was tasked with sifting through decades of deep space data, looking for the subtle fingerprints of gravity, the almost imperceptible wobbles and tugs on distant objects that could betray the presence of a massive unseen world. This was akin to not looking for the pebble itself, but for the minute disturbances its presence might create in the sand around it. And what it found sent ripples of excitement through the scientific community. The AI detected an unexplained gravitational force, something massive moving in the darkness. Trained on millions of observations, filtering out the static of cosmic noise with a speed and precision no human could ever achieve, the AI flagged a measurable anomaly, a consistent pattern of gravitational influence that pointed towards a single, substantial source. If the initial calculations hold true, this could be the first solid evidence for the elusive Planet X. This wasn't a lucky glance through a telescope. It was the culmination of intelligent data analysis uncovering a hidden truth woven into the fabric of our solar system. This groundbreaking discovery wasn't born in a vacuum. It echoes a similar pivotal moment in astronomical history. Remember the tale of Neptune's discovery? Astronomers noticed Uranus, the seventh planet, wasn't behaving exactly as predicted by Newton's laws of gravity. Its orbit showed slight deviations, puzzling irregularities. The brilliant minds of the time hypothesized that another, unseen planet might be exerting its gravitational influence on Uranus. They crunched the numbers, predicted its location, and in 1846, Johann Gale pointed his telescope to the predicted spot, and there it was Neptune, the eighth planet, discovered not through direct observation, but through its gravitational effects on a known celestial body. The discovery of Planet X through AI analysis follows a similar intellectual lineage, a testament to the power of deduction, and now the incredible capabilities of artificial intelligence. The implications of this potential discovery are profound. For centuries, our model of the solar system has been largely static, a familiar family of planets orbiting our sun. The confirmation of Planet X would be the first addition of a major planet to this family in nearly 2 centuries, a paradigm shift in our understanding of our cosmic address. It would mean that our planetary map is incomplete, that the solar system extends far beyond what we currently perceive. Think of it like discovering a new continent on a world map you thought was already complete. What other secrets might lie hidden in those uncharted territories? The AI's findings suggest that this hidden world isn't just a minor asteroid or a distant icy body. The strength of the gravitational anomalies points to an object potentially 10 times the mass of Earth, a true planetary heavyweight lurking in the outer darkness. Why haven't we seen it until now? The AI's analysis offers a compelling explanation. Planet X might reside in a highly elliptical orbit, a stretched-out path that takes it to immense distances from the Sun for the majority of its journey. This unusual orbit could also be tilted significantly compared to the relatively flat plane in which the other planets orbit. Imagine a racetrack where one car occasionally veers far off the main oval, spending most of its time on a distant, less visible part of the track. This orbital eccentricity and inclination would make Planet X incredibly faint and difficult to spot, even for our most advanced telescopes. Furthermore, the AI suggests its atmosphere could be absorbing or reflecting light in unexpected ways, further cloaking it from our view. It's like a master of disguise, its physical and orbital properties conspiring to keep it hidden. The idea of a hidden planet influencing the outer solar system isn't entirely new. Ancient civilizations, with their deep connection to the night sky, recorded celestial events that continue to intrigue us. Some ancient texts speak of a wandering planet, a massive object that appeared infrequently in the heavens. The Babylonians and Sumerians, with their sophisticated astronomical knowledge, mentioned Nibiru, a hidden world with an unusual orbit. Some researchers even draw parallels between these ancient descriptions and the characteristics now being attributed to Planet X. Could these ancient observations, often dismissed as mythology, hold a kernel of truth, a long-forgotten awareness of a celestial neighbor we are only now rediscovering with the aid of artificial intelligence? It's a tantalizing thought, blurring the lines between ancient wisdom and modern science. For decades, NASA and other space agencies have diligently scanned the outer solar system using powerful telescopes like Hubble and WISE. Yet, their searches, primarily focused on detecting reflected sunlight, yielded no definitive evidence of Planet X. It was like searching for a specific radio frequency on an old analog radio dial, never quite hitting the right spot. Google AI's approach was fundamentally different. Instead of looking for a direct image, it sought the indirect evidence of gravitational influence. By analyzing the subtle movements of numerous distant space objects, the AI pieced together a picture of an unseen force at play. It was like a detective not looking for the suspect directly, but examining the footprints they left behind. This paradigm shift in the search strategy highlights the immense potential of AI to uncover hidden patterns and anomalies in vast datasets, patterns that might be invisible to the human eye. The AI's analysis revealed a compelling pattern. Multiple celestial objects in the farthest reaches of our solar system exhibiting peculiar behavior, drifting off course as if being pulled by an invisible hand. This wasn't a random scattering of anomalies. It was a synchronized dance, dozens of space rocks all tilted at the same strange angle, their orbits subtly warped. The precision with which the AI mapped these gravitational effects was unprecedented, pointing towards a single planetary-sized source as the most likely explanation. It was like finding multiple arrows, all pointing towards the same hidden target. The estimated size of this potential Planet X, roughly 10 times the mass of Earth, further strengthens the argument for its planetary status. Such a massive object would undoubtedly exert a significant gravitational influence on its surroundings. But if it's so large, why has it remained unseen? The AI's calculations suggest a key reason: its highly elliptical and tilted orbit. This orbital path would mean Planet X spends the vast majority of its time in the extreme outer reaches of the solar system, bathed in minimal sunlight and appearing incredibly faint from our vantage point. Imagine a shy giant preferring the solitude of the deep darkness, only occasionally venturing slightly closer to the inner solar system. Now that the AI has provided a potential location, the real work of confirmation begins. Scientists are now pointing their most powerful telescopes towards the predicted region of space, hoping to capture the faintest glimmer of light or heat signature from this elusive world. Telescopes like the James Webb Space Telescope, with its infrared capabilities, might be crucial in detecting the heat emanating from such a distant and potentially cold object. It's like finally having a specific address to look for a long-lost friend. However, the scientific process demands rigorous scrutiny. Not everyone is immediately convinced. While the AI's findings are undeniably intriguing, the possibility of a false alarm remains. AI, despite its power, is not infallible. The vastness and complexity of deep space data mean there's always a chance that the AI might have misinterpreted cosmic noise, background radiation, or even the gravitational influence of distant galaxies as the signature of a hidden planet. Skeptics also point to past instances where promising astronomical findings turned out to be misinterpretations. It's crucial to approach this discovery with cautious optimism, subjecting the AI's findings to thorough verification. The crucial next step involves independent verification by other research teams using different observational methods. Scientists will be cross-checking the AI's data with existing astronomical surveys and conducting new observations to see if they can independently detect the predicted gravitational anomalies or, ideally, a direct image of Planet X. The more independent lines of evidence that converge, the stronger the case for its existence will become. If Planet X is indeed confirmed, it would revolutionize our understanding of planetary formation and the evolution of our solar system. Its bizarre orbit suggests it might not have formed in the same protoplanetary disk as the other planets. Instead, it could be a rogue planet, an object that formed elsewhere and was subsequently captured by our sun's gravity. If this is the case, it opens up fascinating questions about the prevalence of rogue planets in the galaxy and the dynamics of planetary system formation. Could there be other captured worlds lurking in the distant reaches of our solar system, waiting to be discovered? The confirmation of Planet X could even reignite the debate about Pluto's planetary status. Pluto was reclassified as a dwarf planet in 2006, partly due to its relatively small size and its inclined orbit. The discovery of a new, massive planet in the outer solar system might prompt scientists to revisit the definition of a planet. What criteria truly define a planet, and how does Planet X fit into that definition? Perhaps one of the most profound implications of finding Planet X lies in the realm of astrobiology, the study of life beyond Earth. If a planet this large and potentially unique has been hiding in our own cosmic backyard, what other surprises might the universe hold? Could there be other undiscovered planets, perhaps even ones with conditions conducive to life, lurking in the vastness of space? The discovery of Planet X would serve as a powerful reminder that our understanding of the cosmos is still far from complete. The potential influence of Planet X on Earth has also sparked some intriguing, albeit speculative, theories. Some researchers wonder if the gravitational pull of such a massive, distant object could subtly affect Earth's orbit, potentially influencing long-term climate patterns, ocean currents, or even the frequency of extreme weather events. Others have even speculated about a link between Planet X's gravity and seismic activity, suggesting it might contribute to earthquakes or volcanic eruptions. While these ideas are not widely accepted within the mainstream scientific community, due to the vast distance involved, they highlight the interconnectedness of our solar system and the potential for even distant bodies to exert subtle influences. Furthermore, some have theorized that Planet X's gravitational perturbations could disrupt the orbits of asteroids and comets in the outer solar system, potentially increasing the frequency of asteroid impacts on Earth over geological timescales. These are fascinating areas of ongoing research and speculation. If Planet X is confirmed, the next logical step would be to learn as much as possible about this mysterious world. What is its precise size and mass? What is its atmosphere composed of? Does it have moons? Sending a space probe to such a distant object would be an immense technological challenge, requiring advanced propulsion systems and decades-long travel times. However, the scientific reward for such a mission would be immeasurable, offering us a first-hand look at a completely new type of planet in our solar system. The success of Google AI in potentially uncovering Planet X underscores the transformative power of artificial intelligence in scientific discovery. AI's ability to analyze massive datasets, identify subtle patterns, and make connections that might elude human researchers is revolutionizing fields ranging from astronomy to medicine. In the context of space exploration, AI can act as a tireless and incredibly efficient research assistant, sifting through vast amounts of data from telescopes and space probes to uncover hidden trends and anomalies. This capability opens up exciting possibilities for future discoveries, from finding more exoplanets to detecting faint signals from the early universe. Imagine AI algorithms sifting through the data from future space telescopes, automatically identifying potentially habitable exoplanet or detecting unexpected astrophysical phenomena. The story of the search for Planet X is a testament to human curiosity and our relentless pursuit of knowledge. From the initial observations of orbital anomalies to the application of cutting-edge artificial intelligence, it's a journey driven by a desire to understand our place in the cosmos. If Planet X is indeed found, it will not only be a monumental scientific achievement, but also a humbling reminder of the vastness and mystery of the universe that still surrounds us. So, what happens next? The scientific community is holding its breath, awaiting further confirmation of the AI's findings. Telescopes are being pointed, data is being analyzed, and simulations are being run. The coming months and years promise to be an exciting time for planetary science. Will Planet X finally step out of the shadows and reveal its secrets? Only time will tell. What do you think? Could this be the dawn of a new era of planetary discovery, powered by the incredible capabilities of artificial intelligence? What other secrets might be lurking in the vast cosmic ocean that surrounds us? Share your thoughts and theories in the comments below. Wishing you clear skies and a universe of wonder. Stay curious, and don't forget to subscribe for more exciting stories from the frontiers of science and exploration.